Hey kids! Playing some Jack Johnson for today's video, Algebra 1 students, measures of variation. We're going to have a lot of definitions in this video. I'm going to try and keep it on the short side. We're not going to be doing much with these definitions or with these concepts until the next marking period, but we're trying to go ahead and keep up with the pacing guide that they have set forth for us. So, let's start with hey diddle diddle, the median's the middle. You add and divide for the mean. The mode is the one that appears the most, and the range is the difference between. How cute. And it does give you the basic overview, but let's do a little bit more in depth with the definitions. Okay, so we know our basics with statistics. We know we have measures of variation. Variation, we're talking about how the numbers in a set vary. Now the thing with statistics that I want you to remember is that you've learned it very algorithmically. And you're probably asking yourself, well, what the heck does that mean, Miss LeCompte? What's algorithmically? You see this little robot guy here? That's how you've learned these concepts. I set up the numbers, I add them all up, I divide by how many I have, and that's the mean. That's great, but what the heck is that? What is it talking about? So let's, real quick, I'll go ahead and I'll just put in some definitions for you. I'm just going to write them in and then read them through for you. So let me pause this real quick. Okay, so the mean, the numerical average. Add them all up, divide by how many you have, which we already established. The median, the middle number in a set. The mode, the most common. The range, the largest minus the smallest. And a statistical line plot, which is a method of displaying data with a number line and x's. So going back to what I said, you've learned this algorithmically, and that means that you've learned how to find these values, but you don't really have a lot of background on the usefulness of different ones as opposed to others. Okay, mean and median have very different uses. It's important to recognize that the mean does not always well describe a set of data. Imagine for me a list of home prices, and I'm just going to give you three. All right, so one home, say, is about $150,000 home. So that'd be like your average house in your average neighborhood in Hampton. Another one, about the same $165,000 home. Then say you go a couple of neighborhoods over and around a corner and you find someone who had an extreme home makeover experience, and their home value is $3,500,000. So if I find the average of those three numbers, I'm not finding a number that really describes Hampton, am I? Because this number is going to way skew the mean up, way up. Okay, you can find it on your own if you want, but in the interest of time, I'm just going to tell you this number would make the mean really high. Now, the median would be this one in the middle, and that does accurately basically describe Hampton. So it's important to recognize the difference between mean and median, and we'll have some experiences in class where we note that the mean is not always going to be your best measure of variation. Sometimes your median is better. So in terms of review, those are the common ones that we should recognize: your mean, median, mode, range, and what statistical line plots are. Let's look at some new ones. Okay, box and whisker plot. That's something we're going to be making. And the upper and lower quartiles and the extremes have to do with that box and whisker plot. And while some of you may have learned how to make box and whisker plots, most of you have not. So I'm going to give you the basic definitions here on this slide. So let me pause it and write some stuff in for you, and then we'll go over it real quick. Okay, so a box and whisker plot is a method of displaying data. Okay, and this right here, this is a box and whisker plot. And what happens is we end up putting it on a number line that it's all evenly spaced out for us all the way down. And you take your data and you have to find several important values. One of them we already know, that's the median. It goes in the middle just like the median always does. What you can do with a box and whisker plot then is you can find the middle of the bottom half of your data and the middle of the top half of your data, and those are called quartiles. Okay, the lower quartile here, the upper quartile here. And yes, of course, we'll do an example, don't worry. The highest and lowest values are also on a box and whisker plot. They're called the extremes. Just like your fingers and your toes are your extremities. With the cold weather, it's been very important to keep your extremities warm. So we'll learn later in this video how to lay all of this out. Okay, and what it lets us do is it lets us see how the numbers are dispersed, how the variation is. Okay, and with that in mind, let's look at some more definitions. Some things we're going to look at after the break. I'm not even going to define them for you today, but something I want you to start thinking about. These three, variance, standard deviation, and mean absolute deviation, are all about measures of dispersion, how data is spaced out. Now that's important. It's important to recognize how data is spaced out. We'll also learn about the normal distribution. Why is it important to learn about how data is spaced out? Well, think about test scores. It's important for me as a teacher to know where the scores were. Were they all passing? Were they all failing? Were most of them in one part of the number line or another? Population versus sample, this right here has to do with what you're actually talking about. And you might talk about this in science. Population, that's everyone, okay? All, say, for example, that would be everybody at Spratly. A sample, however, would be just a snippet, just one group of the population. All right. And we're going to be, we are jumping around a little here, just talking in terms of definitions first. But these are things we'll talk about later on. Variance, standard deviation, and mean absolute deviation, that's the heavy statistics we do this year. And we'll talk about those second semester. Let's look at the mean in a couple of different ways. Now, there are three ways to think about the mean, and the first one is as fair share. And here we have Barney, because sharing is definitely caring. Let's read through this problem together. 6 kids brought the last of their Halloween candy to school to share with one another. The students had 1, 2, 2, 2, 5, and 6 pieces left, respectively. Let's pretend this is the end of November that this problem is happening and not now, because if you still have Halloween candy, ew, eat that stuff or get rid of it, because that's gross. Anyway, they pool their candy together because it's so nice to share. Remember Barney? How many pieces of candy will each kid get? Well, if we pull all of that candy together and divvy it up to each person equally, that's fair share. And the mean of all those numbers would represent a fair share. So if I think about what I would have to do is I'd have to evenly distribute it out. And if we add it all the way up, there's a total of 18 pieces of candy. Okay, 18 pieces of candy divided by 6 people, 3 pieces per person. And what you would do to see the fair share part of it is you could actually give each kid, you could actually take the kids, have them give pieces of candy until everyone has an even amount. Okay, then there's mean as balance point. And here you have a cute little seesaw over here. Mean as balance point, little frogs on a seesaw. You can look at the mean as the balance point in a distribution. If the numbers are spaced out on a number line, the center of the distribution is the mean. Let's look at an example. This is the same one we just did with the Halloween candy. This is a statistical line plot right here. So 1 kid had 1 piece, 3 kids had 2 pieces, 1 kid had 5, and 1 had 6. And what you can do is find where's the middle, where's the center, where's the balance point. And we're going to do a really cool activity with this and post-it notes in class. But what I'll just show you is that you can just keep moving your numbers in 1 from each side until you find that balance point. And in this case, that balance point is the 3. And we'll see a specific example in class. But if I was to take, you can actually take like a paper towel roll like this, and you can measure out. So 1, 2, 3, 4, 5, measure it out. So say it was 12 inches long, every 2 inches, put a little mark. And take 6 coins of equal weight and glue them on like so. Your balance point, you could actually take that paper towel roll and try to balance it on your finger or on a ruler. That balance point would go right through the 3 because that's where this would balance out. Now, if you end up trying it, go for it. Maybe I'll try it myself and bring in the example. Okay. So the center, the balance point, is at 3. Then there's, of course, mean as numerical average, the traditional definition of the mean. So that would be in the case of actually adding all the numbers, much like we did to find the fair share, since I can't actually sit around in a room with 5 of you and divvy up candy until we all have an even amount. That's adding them all up, dividing by how many you have. That was 18 over 6, and it was 3. So finding the mean, just a plain old regular average, just adding them up, dividing by how many you have. Okay, but I think it's interesting to think about that fair share and that balance point example, because the mean does not have to only be I add them all up and divide by how many I have. I add them all up and divide by how many I have. If that's the only way you think of the mean, it's limited. Okay, it's limited. And we'll look at some more examples in class. Sadly, this slide had to be re-recorded because of a little bit of a glitch where it just didn't want to record my writing. So there won't be any music on this one, but let's go ahead and walk through how we find the values for a box and whisker plot. So in order to make our box and whisker plot, we need the median, The quartiles, that's lower quartile, that's what LQ stands for, and upper quartile, UQ, and the extremes. Extremes, that's easy. Let's do that first. Extremes would be your lowest and highest number. So that would be your 3 and your 8 are your extremes. Median, okay, well we've learned how to find the median. Now I don't want to see you do that nonsense where you cross off the numbers on either side. Instead, I'd rather you think of it numerically. I have a set of 1, 2, 3, 4, 5, 6, 7 numbers. So which one is the middle number? Well, cut 7 in half. 7 divided by 2 is 3.5. 3.5 rounded up, excuse me. That's your middle number. So your median is going to be 5. It's in the middle. The lower quartile, remember, well, I may not have told you this actually yet because I think that was in the old version of this slide, is the median of the bottom 50%. The lower quartile is the median of the bottom 50%. The upper quartile is the median of the top 50%. So, take your bottom 50%, looking at right here, and where's the middle? Right here, the 4. Take your upper 50%, where's the middle? Right here, 8. So I now have my numbers. My median is 5. My lower quartile is 4. My upper quartile is 8. And then my extremes are 3 and 8. And we're going to utilize those numbers to make the box and whisker plot on the next slide. If you recall correctly, we had a a data set of 3 all the way through 8. So we're going to draw a number line. 3, 4, 5, 6, 7, 8. Not bad. Yes, you number it, all of them. I know that we didn't have 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7. Okay, good. For a second there, I thought I counted wrong, which, irony, but the math teacher can't always count correctly. You do go ahead and draw a regular old number line with everything laid out on it. And then we're going to take our numbers that we had on the previous slide. We've got a lot of information. We have, so we start with extremes. So let's put a point. I like to draw it above my number line. One at 3 and one at 8. There's our lower extreme and our upper extreme. Okay, so we got lower extreme. I'm going to work with me here, iPad. Sorry for the editing jump. Upper extreme. Now let's do our quartiles. So our lower quartile, go back and look at your notes, was at 4. So put a little dot at 4. And our upper quartile actually also happened to be at 8, didn't it? So our upper extreme and our upper quartile are the same value, while our lower quartile is a little bit lower. So it makes for a little bit of an awkward box and whisker plot, but it's only our first one. We'll have more to practice. Oh, and by the way, the calculator can totally do these for you, as it can all the other statistics, as long as you just type in the numbers correctly, and you're going to learn that in class too. The last one we have to put on here is our median. So our median was at 5. Median was at 5. And so now we draw the box and the whiskers. The box, so this was our median right here. The box part of it goes from lower quartile to upper quartile. And you draw a rectangle like that. The whisker part would be from quartile to lower extreme, and then it would be here quartile to lower extreme, but they happen to be the same number. Then draw a line down through the median. Right there. What does this tell me about this data? Well, I now see how it's distributed. This data is skewed toward the upper extreme. Every part of the box and whisker plot is a percentage of the data. The median is the middle, right? So below the median, there's 50% of your information. And above the median, there's 50% of the information. So that means that between the lower extreme and the lower quartile, that's broken up into 25% or 1/4, and 25% or another quarter. Same thing here. And then if we had space in between the two, there'd be 25% there also. So you can say you can talk about this data now. You can give me an idea of how it's distributed. Say this was about test scores and this was how the data was distributed. Oh, people did pretty well on this test. Most of the scores were skewed up towards the higher extreme. So box and whisker plot is a method of displaying data. So I know I went kind of quickly through this one. I didn't give you a ton of information, just lots of definitions, a little bit of review. The more hardcore statistics we'll do in class during second semester. One of the activities that we get to do with this is the human box and whisker plot, which is one of my favorite things to do in class. So I'm pretty excited about that, and we'll do that right after the weird week with the exams and all that. All right. I hope you enjoyed this video. I hope it wasn't too long, and I will see you guys in class.